And now let's find the center of mass. So we've got a parabola. So with this, you don't really need an extremely accurate picture, but you should at least understand which one of the two functions is on top and which one is below. So we've got the parabola like this, and then this is going to be a line with positive slope, and it's going to cross the x-axis at 3. So it's going to look something like this. So this is the region being talked about, because this is the only finite region between them. This would be an infinite region, so we can never find that. And the same over there. So it's talking about this region. So find the center of mass. So where would be the balancing point? Just as a guess, I'm just guessing it's right there. If you actually cut out this piece of paper and tried to balance it on a pen. Okay, so we have that the top function is the 2x plus 3. And then the parabola is on the bottom. And then we get to set up and do 3 integrals. Sorry about that, bump the table. So the first thing to do is find the area or the mass. So the difference is the area would just be how much space is taken up by this black shaded region. And then you would say, well, this paper actually has a density. So if you multiplied by the mass density, then you'd get the total mass. And we're just pretending that it's a constant density, which this paper pretty much is. I'm sure that it's pretty close to being a constant density. And because at the end we're going to divide, so if you had the density, which is usually a delta function, at the end we're going to be dividing. And because it's constant density, these are going to cancel out. In Math 3C, you can have this as an actual function instead of just a constant, and then they don't cancel out. But that's for third semester calculus. So for the mass, we just need to find out, well, for one thing, we need to find out the limits. Where are these two things crossing? So where's this point, and where is this point? So let's see. If you have x squared is equal to 2x plus 3, and then if I put everything on one side and set it equal to 0, I tried to make this up so it would just factor, so I don't have to use quadratic formula. Let's see if it works. So an x and an x, a 3 and a 1, and this one could be negative, and this one could be positive. And then that would leave a negative 2x in the middle. So it turns out that we've got x equals 3 and x equals negative 1. So this is the negative 1, this is the 3. So when we set up the integral, it's going to go from negative 1 to 3. And then we just need the top function minus the bottom function. So it's a 2x plus 3 and minus x squared. And then integrate that. So there's no algebra or anything we need to do first. Just go ahead and integrate each one. So the antiderivative of this would be x squared over 2, which is going to cancel that 2. So the antiderivative is x squared. For the 3, the antiderivative is 3x. And for x squared, the antiderivative is x cubed over 3. And then evaluate from negative 1 to 3. So if I substitute a 3 in there, there's 3 squared plus 3 times 3 minus 3 cubed over 3. And then minus, when you substitute a negative 1, this is going to be negative 1 squared, so that's positive 1. This will become a negative 3. And then we have, oops, I said it, but I didn't write it. So this becomes a negative 3. And then minus, when you substitute a negative 1 cubed over 3. So what does all of that equal? So this is going to be a 9 plus 9. So far we have 18. Here, this would be 27 divided by 3. So that is 9 negative. And then minus, so we've got this is -2, and then this would be 3 negatives in a row with another negative means that it's positive. So we have -2 and then plus 1/3. So the mass is going to be 9 for these two. And then this would be -1 2/3. But with this is going to become positive 1 2/3. And then 1 2/3 would be 5/3. So that is then, what's this? 27 plus 5 is 32/3. And then just real quick, I'm going to check and make sure that I got this right. So I'm going to have the calculator integrate that and see if it's 32/3. And the calculator is going to give me a decimal, so this would be, what would that be? 10 would be 30 with a remainder of 2, so 2 out of 3. So I think the calculator is going to tell me 10.667. And then what I need to do is say, all right, I need, sorry, let me focus in on the calculator. So let me have a 2x plus 3 minus x squared. And then the graph is going to look different because of this subtraction, but I should still get the 10.667. So then go to second, calculate number 7, and go from -1 to 3. And it says it's a 10.667. So that's good news. All right. Then back to this part. So now we're 1/3 done with the integrating. And then to get it to focus, it usually works if I use my hand. Sorry about that. All right. Okay, so then the next is we need the moment about the x-axis. And for the moment about the x-axis, you integrate, and it's still going to be from -1 to 3. And then you take the 1/2 and you subtract the two functions. So that's going to look just like this. 2x plus 3 minus x squared. And then you add the two functions. So 2x plus 3 plus x squared. And now for this, I would look at it as basically somebody factored the difference of squares. So when you multiply, just group this 2x plus 3 together. And when you multiply those two, that's going to be 2x plus 3 squared. So there's going to be a 2x plus 3 squared. And when you multiply this to the positive x squared, and when you multiply this to the negative x squared, they're going to cancel. So the next thing I need is just the negative x squared times the positive x squared. So that's minus x to the 4th. All right, then let's do the antiderivatives. So there's going to be the 1/2 still. And then for this one, just add 1 to the exponent and divide by that number. So there's going to be 2x plus 3 cubed, and then divide by that number. And then don't forget the chain rule. The derivative of the inside would be 2. And since we're doing antiderivatives, you have to divide by that 2. And then for this one, it's going to be minus x to the 5/5. And then evaluate that from -1 to 3. And then substituting the 3. So we've got negative, there's the 1/2. When you substitute a 3 in here, this is going to be 6 plus 3, so that's 9 raised to a 3. And then it's divided by 6. and then substitute a 3 over here, so that's going to be minus 3 is raised to the 5th over 5, and then minus when we substitute the negative 1. So when you substitute a negative 1, this is going to be negative 2 with 3 is just going to be 1. So this is going to be 1 over 6. And when you substitute a negative 1 in here, that's going to be negative 1 to the 5th. So that's negative 1. But then with this, it's going to become positive 1. And then I put the subtraction from the top limit minus the bottom limit, put that in parentheses. The whole thing's in brackets. And then what does that equal? Well, with things like 9 to the 3rd and 3 to the 5th, of course, everybody can do theirs in their head. That's easy enough. But the calculator probably is getting lonely, so I'm going to give the calculator something to do. And try to get the whole thing on the page. Sorry about the adjusting. Okay. So we've got a 1/2, and then there's 9 is cubed divided by 6, minus 3 is to the 5th divided by 5. And then I need minus parentheses a 1/6 plus a 1/5. And then that equals that number. And to make myself look smart, I'm going to say change that to a fraction, which is 544 over 15. So 544 over 15. And now we are 2/3 done. The next thing to do is find the moment about the y-axis, and then that integral is a little bit easier. The moment about the y-axis is going to be, you integrate again from -1 to 3, and then it's going to be x, and then you subtract the two functions. Again, the top one minus the bottom one. And with this, okay, there's nothing combined here, but I should go ahead and multiply through by x first of all. So I've got a 2x squared plus a 3x minus an x cubed. And then find the antiderivatives. So this is going to be 2x to the 3 over 3 for the first one, plus 3x squared over 2, and then minus x to the 4 over 4. Evaluate from -1 to 3. So substituting the 3 is going to be 2, and then 3 is cubed over 3, plus 3, and then 3 is squared over 2, and then minus 3 is raised to the 4th over 4, minus, and put parentheses. So when you substitute a -1 in here, that's just going to leave -1. So this is going to be a -2/3. When you substitute a -1 here, it's going to square the negative, make it a positive 3/2. And then when you substitute a -1 to the 4th, it gets rid of the negative, so it just leaves -1/4. And then, should we use the calculator? Let's see, this would be 27 divided by 3, so that's going to be 9 times 2 is 18. This is going to be 9 times 3, so that's 27 divided by 2. And then this is going to be 81 divided by 4. Maybe I should have just used the calculator. I'm going to end up using the calculator anyway. And then for this, I'll go ahead and distribute the negative. So positive 2/3 minus 3/2, and then minus 1/4. And then what does that equal? So let me do it without adjusting for the calculator. I'm sure you know how to type fractions into a calculator. And then see, I'm almost done. Faster if I don't adjust the screen. And then if I go to math and change it to a fraction, it says it's 61 over 6. Okay, so remember that for the m, we got 32 over 3. And for the moment about the x-axis, we got 544 over 15. And for the moment about the y-axis, we got 61 over 6. And finally, we can find the center of mass. So the x is going to be